What's up, everybody? This is page 365. We're on activity 2, interior angles of a circle theorem. And just like we did in the previous lot of videos on proving that we had the inscribed angles of a triangle, the 180 relationship, we have to develop our own understanding of how a proof can possibly happen from some practice on our own. If you go back and look at page 355, our work today is directly related to the learning goal that we're going to determine the measures of angles formed by two chords, two secants. And we're going to therefore prove the interior angles of a circle theorem and then continue on our journey. We are probably going to need to use our vocab word. So if you haven't yet made a vocab word note card, please do so. To be ready for today's activity, you're going to need a compass. So I got my 3D printed one. And then you're probably going to need a protractor to help measure angles if you don't have that information for measuring angles already. And let's get into it, all right? We are reasoning abstractly and quantitatively, and we are constructing viable arguments and critiquing the reasoning of others. Okay, step 2. Question 2. It says, draw a circle with two chords that intersect inside of it. And let's do that. All right, so I got my compass, and I'm going to go ahead and pin it down so that I can then draw my circle. I'm going to make my circle be like this big. That's big enough. I'm going to make it wrap around. You just need something that actually creates a circle shape. It doesn't have to be like a specific size. Because that's my center, I might as well label it O. And now I need to draw a circle with two chords that intersect it. And I'm actually going to say, don't draw chords, draw secant lines. But label the places where your secant line crosses. So I'm going to do something kind of like what we did on the previous page, but I'm going to draw it on the other side. I want it to be just different enough that you weren't expecting it to happen. Okay? So there's one secant line, and it's going to cross at A, B. So the chord that I'm talking about is actually just the distance from A to B. Now I'm going to draw a second secant line, probably something like this. I want to draw secant lines, not chords, because my compass, it's a pretty big compass. And if I draw only like a little circle like this much, my compass will be bigger than any measurement. So I'm just going to have to extend the lines anyway. We might as well label this C, E, and D. So it's kind of similar to what we did on the previous page, page 364. All right, use measuring tools to determine the measure of an angle formed by the intersecting chords and the measure of the arcs that are intercepted by the angle and its vertical angle. Use measuring tools to determine the measure of an angle formed by the intersecting chords. Okay, so I guess this right here is saying, how big is that angle? And also, likewise, how big is that angle? And I'm going to put 2 spikes on them. And I think I'll label point E up here. If I know those two pieces of information just from measuring it all out, then I should be able to come up with a prediction for these two chords that are in the measure of the arcs. Okay, so we also need to know the measure of the arcs. So the measure of the arcs here would be like AD. We'll color that orange. And BC, we'll color that one green. So it looks kind of like the work that we did on the other page. Okay, here's the deal. I can just straight up measure angle E, specifically BEC. The measure of angle BEC, and I'm going to get a number. So protractor, put the circle or center of the protractor on point E, and then we're going to line up the protractor so that our zero angle line is on our secant line. And then if we look out here, this angle, we want to talk about how big this angle is. So I'm going to go from 0, 10, 20, 30, 40, 50, 55, 56, maybe 57. I'm going to say 56 just to be, I don't know, if I'm wrong by like a tiny amount of a degree. That's a 56-degree angle. Let's do the same thing. From point E, measure angle AED. The measure of angle AED is. Okay, so protractor, center it up. Let's line the protractor up so that the circle, the zero angle are all lined up. And then now, see, I can even tell I didn't draw this line long enough. I'm actually going to recenter the protractor to go on a different spot. I know that this line right here is long enough. Okay, centered, lined up, Okay, lined up here, 10, 20, 30, 40, 50. That's really the same. Oh, of course it's the same angle. They're vertical angles. Duh. Okay, so this is also a 56 degree angle. That's an oh my God moment right now. Like, how did you forget about that? In order for me to figure out the measure of this arc, well, I'm going to do a little bit of magic. I'm going to go back to what I said at the bottom of page 364, which was the sum of the vertical, or the sum of the arcs for the vertical angles is divided by 2. So really what I can do is at least haphazard a guess that if I double the 56, then technically the measure of AD, so that's the orange arc, and the measure of arc BC should be double of 56. 2 times 56, which is about 112 degrees. So now I just need to kind of confirm it, right? I should get 2 numbers from measuring the central angle. So I'm going to use a different color now, maybe even like a pencil, or at least I'm going to use red ink instead of. And I'm going to make a vertical, and I'm going to make a central angle here. So nice long lines. And again, nice long lines. And I want to find the measure of this angle. So I'm going to get I'm really right now going to get the measure of angle MAD. Okay. Center up, 0 up. I'm using the red measurements, and if it's all lined up and perfect, this looks like 10, 20, 30, 50, 60, 70, 68 degrees. This looks like a 68 degree intercepted arc. I'll put that right here, 68 degrees. That's mine, of course, and if you're straight copying me, you're not doing it right. You need to actually go figure it out for yours. Follow my steps, use what I'm doing to help know what you need to write for yours. Okay, let me go like this, draw that out. Maybe I'm a little bit off right here, but I'm close enough, right? So I've got, again, red central angle BOC. It's going to be the same as the arc that's intercepted here. So line everything up. Let me do a little bit of like subtraction. What's 112 minus 68? 54? 54? I think it's 54 degrees. 44 degrees. I'm kind of cheating the system now. Okay, so I'm going to look here. I've got everything lined up. 10, 20, 30, 40, 43, which in essence is almost 44. So I'm going to go ahead and just acknowledge that I have a 44 degree angle. When you add 68 plus 44, you do in fact get 112. So now I can say I know the measures of the angles AD and BC, which is going to be added together. You divide by 2 and you get the interior angle that doesn't touch the center. Consider the different measures you determined. So let's go ahead and move on to number 3. Consider the different measures you determined in the circles from question 1 and question 2. So the pattern, right? The pattern that I'm hoping to establish here is that the interior angle, and maybe you do just straight copy what I'm saying, but think about it before you write it down. The interior angle is equal to, its measure that is equal to the sum of the intercepted arcs created by vertical angles. So there's our vertical angles right here. Let me highlight in yellow. We have this angle, which is 56, and we have this angle, which it's vertical. So it should, oh, you didn't see it. Here's my highlight. Right, here are vertical angles. They're both the same. They're both 56. I measured them. But these intercepted arcs, when you add them together, they're created by vertical angles. The sum of the intercepted arcs created by vertical angles divided by 2. It's almost like we need a formula, right? So we're probably actually pushing for a formula. I'm going to try to like put one out there right now, and that is this. The measure of angle I for interior angle, it's going to be equal to intercepted arc 1 plus intercepted arc 2 divided by 2. That's kind of like a formula we can use. Okay, let's explore your conjecture for a circle where the vertex of the interior angle is at the center. We've actually seen this one before. We've seen this one where we've said this intercepted arc and this intercepted arc, they're created and they're going to be equal to the central angle. Well, here's the thing. This angle right here, this angle O, so I'm going to use, say, the measure of angle BOP. Angle BOP, I've colored it in red. The measure of angle BOP is therefore equal to the measure of arc BP and the measure of arc FD divided by 2. Which is kind of what's set up here, right? We've set up here right here. So we said that's a repeat logic. But the thing is, because the way that a central angle is created, the angle BOP is a central angle. So therefore, angle FOD, F-O-D, is also a central angle. And it's equal to the same thing as angle BOP because of the way it's created. So this amount, like this interior angle, is the same and the same. So I guess technically both of these are the same. We could just replace FD with BP with our PAL substitution. So this could be the measure of BP. Now I'm going to replace FD with what it's equal to. FD and BP are the same length because of how central angles are created. So there's actually 2 BPs if I do a substitution. So 2 things divide by 2. I mean, these 2 things can just be written as 2 MBPs. And we're dividing by 2. And so the 2's cancel. Still the same thing. Nothing has changed, no matter where we put our central angle. But central angles, right? Central angles are just equally identified. They're kind of nice. They're a special case of nice. That is the rest of this page. We're going to do page 366 next. Continue to talk about the interior angles of a circle. Thanks for watching. Stick around. See you in the next video.